Are you ready? Okay. Can you hear me? Boleh dengar?
Boleh.
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 Cheese and chapter. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. So we'll start the class with the Ummul Kitab Al-Fatihah. Okay, so today we will continue our lessons on the rotational dynamics, which is in chapter 7. So we already learned chapter 1 until chapter 6. So right now we continue to learn chapter 7. So in chapter 7 we learn some things that related to rotational dynamics. Okay, the rotational dynamics is also relates to rotational kinematics that we learned last week. Okay, so let's look at the learning outcome first. Okay. One moment. Okay, this week will be week 8, okay, minggu ke-8 ya. So obviously, so this is rotational dynamics, so we learn something about torque. Okay, so you need to define torque at the end of the session, of the end of the lesson. The student should be able to define torque, okay, apply the definitions of torque on object undergoing rotational dynamics, state the two conditions of mechanical equilibrium, and apply the conditions of equilibrium to solve problems involving torque. Okay, define the center of gravity, but this one is under qualitatively. Okay, and apply the conditions of mechanical equilibrium, define a moment of inertia, apply a moment of inertia for various objects, apply rotational seconds law to physical system, and state the apply of principles of the conservations of angular momentum. Okay, so basically we already learned rotational kinematics. So in the rotational kinematics we learn some things about motions, but in rotational. Okay, so that is also include the use of equations. Okay, the use of equations of linear motions, but we have to transform it to the rotational equations, which is involving theta, omega, and also alpha. Okay, so in that case, you should always relate that value to the one that we want to learn today. Okay, because that is also relates to what we learned last week. That's why in the 7 and 8 week we learn some things about rotational motions. Okay, but last week we concentrate on the rotational kinematics. Okay, but today we want to continue in the rotational dynamics. Okay, in the rotational kinematics we learn about rotational motion for, let's say, position. Okay, we also discuss about rotational kinematics in terms of velocity and also acceleration. So when we convert it into rotational motion, now positions become theta. Okay, velocity becomes omega, and acceleration becomes alpha. Okay, so in that case, the rotational kinematics will provide a lot of informations, including the equations involved. Okay, but here, okay, we want to discuss more in terms of rotational kinematics and how can we use theta, omega, and alpha in other forms, such as force, such as energy, such as momentum. Okay, so can that forms of terms be transformed to another terms? okay, in the rotational dynamics. So that's why we have to make sure that we learn rotational dynamics. All right. So let's stop sharing about this. So concentrate more on the lessons. Okay, let me do sharing. If you do have a question, then please ask me directly, okay? So, all right. So today we want to discuss on in terms of rotational dynamics, okay? Rotational dynamics. The word dynamics means, okay, we want to further, we want to discuss more in terms of what happened to the force. Okay, because before this, in the linear motion, we learned about force. After we learned X, V, and A. So after that, we learn about force. And we want to know what happened to the work done. Okay, work in the rotational motions. Okay, work in the sense of energy also. Okay, and maybe you want to learn about momentum P, but in the rotational. Okay, what happened to the F, W, and P? So that's why we will have to discuss the rotational dynamics. So this is also involve rotational, okay, rotational motion. As we know, the rotational motion comes with the alpha, comes with the omega, and also comes with the theta. Okay, because this one is also comparable to alpha is comparable to A, omega is also comparable to V, and theta is also comparable to X or Y. Okay, all right. So in this case, this is torque, right? So what is torque? Torque and its two conditions for equilibrium. Okay, the center of gravity, the examples of the object in equilibrium. Okay, how can we say the object is in equilibrium? Okay, and the relationship between torque and angular acceleration, and lastly about angular momentum. Okay, so basically torque, right? You always know what is torque because I think most of you okay already learn about torque, not really learn, but you know the word torque. Okay, definitely the torque comes from at least everybody, especially the boys side or maybe at the girl side, know about car, because car is always relates to torque, always relate to the speed. Okay, so what is torque actually? So from experience, we know that the same force will be much more effective at rotating an object such as a nut or a door if our hand is not too close to the axis. Okay, basically in this kind of form, so you will see. Okay, let's look at the first thing first, the wrench. Okay, so what we call it as we always use this thing, okay, to tighten up the nuts. Okay, let's say this is your nut, okay, and this one, when you have force number one and force number two, okay, you should know which one will give you much force or less force. We will compare between F1 and F2. Okay, definitely we will hold this what we call as spanner. Okay, we will hold these things, all right, at F1. Why we don't hold this at F2? Okay, that must be different between the length between R1 and R2, because the length between F1 is called R1, and the length from the force to and to the nuts is actually R2. So you can see that R1 is greater than R2. Okay, so in this case, F1 needs more, okay, with, okay, because of the length, okay, so it also depends on the length from the center. Okay, this one is called center of rotation. Okay, so that is one case. Another case is a rotating door. Okay, a revolving door, it's a revolving door. Okay, the force between the man, this man, and also this girl. Okay, this girl only needs a few force compared to this man. Okay, it's only because force yang diperlukan oleh budak perempuan ini hanya sedikit berbanding dengan force yang dia lakukan oleh lelaki itu. Why? Okay, why we need to do that? Alright, so we need to make sure why this happened. Okay, this is all because of torque. Torque. So what is torque? Okay, we define a quantity called torque. So torque is actually RF. Okay, torque is RF. R is the lever arm, and F is the force. But torque is actually the multiplications of two vectors. But this one involving cross product. Okay, multiplications is a form of multiplications of vectors. Okay, but in this case, in the form of cross product. We know from work is actually F equals to F dot D. So this one is also the multiplications of vectors, but this one is the dot product. Okay, dot product will give you scalar quantity, but cross product will give you a vector quantity. Okay, cross product will give you vector quantity, while dot product will give you scalar quantity. Okay, what does it mean by scalar quantity? It only contains magnitude. But for the vector, it contains magnitude and directions. Okay, so remember, torque is a cross product. So cross product, okay, when you multiply R and F, it involves cross product. So cross product means we must have magnitude and directions. Okay, so the SI unit for torque is not Newton meter. Okay, why Newton? Because force is Newton and R is in meter. So you need to confirm, you need to make sure that all values must follows SI unit. Okay, to get SI unit for torque will be Newton meter. So the torque increases as the force increases and also as the distance increases. Okay, so either force or distance, it will increase. It will also increase the torque. Okay, so both have the same complement to each other. Okay, when R increase, F also increase, and torque also increase. Either one, maybe R will increase, force maintains the same value, so the torque will increase. But if the force maintain the same value, if the force increase and R maintain the same value, the torque is also increase. And please remember that the SI unit for torque is Newton meters. Okay. All right. So what kind of torque we are talking now? Okay. So in this case, okay, nampak ada dua tempat permainan ni, kita tengok which one yang menghasilkan torque ataupun which one yang menghasilkan force. Okay. Sebenarnya kita biasa jadi macam ni ya. Kita biasa tengok dekat taman permainan, tengok ada satu keadaan kita tahu ini ialah satu permainan berpusing yang sepatutnya this guy, okay, seorang abang ni untuk nak bagi adik-adik dia duduk di atas revolving this thing, okay, sepatutnya ada dua cara digunakan. Okay, satu, dia akan, okay, katakanlah this one is the center of rotation. Okay, center of rotation. Okay, di tengah-tengah tu. Dan cuba tengok betul-betul dan antara center of rotation ke tempat lelaki yang berbaju putih tu, kita namakan dia sebagai R. Okay. Sometimes kita boleh panggil dia sebagai radius, kadang-kadang kita boleh panggil dia level arm. Okay, level arm. Maksud dia panjang daripada center kepada force. So let's say this is your point. Okay, so dia gunakan dua cara. Yang pertama ialah dia tarik. Dia tarik sama directions dengan level arm tadi. Okay, dia tarik, dia gunakan force, dia apply force, but the same directions, parallel to the radius ataupun to the level arm. This one is parallel. Okay, and the other one is dia tarik tapi with the angle theta. Right? Ada angle theta. Maksudnya dia tarik sedikit ke kanan daripada A. Ni A ada two sets of scenario dekat sini. Ada scenario A and scenario B. In scenario A, kita tengok, okay, force is parallel to the level arm, and in the figure B, force have a small amount of theta and have been divided into component, which is component X and also component Y. Okay, in this case, it will certainly have two components, which in this case have sine theta, and because of this is the F that we are talking now. Okay, ini F dia tarik ke arah sini, and angle theta tu ialah daripada angle level arm, angle yang straight line ni kepada level arm, daripada level arm direction dia kepada F. Dan theta dia kat sini lah. Right? And then of course disebabkan itu kita akan divide dia kepada komponen. So atas ni ialah F cos theta, dekat bawah ni ialah F sin theta. Persoalan ni ialah untuk torque, yang mana yang akan bagi value? Okay. So torque akan kira yang mana? Okay, let's say kalau kita ambil theta sebagai 0. Okay, theta 0. So adakah force, kalau kita tengok F cos theta atau F sin theta yang akan bagi value bila kita calculate torque? Okay, antara dua tu antara F cos theta dengan F sin theta. Tak kisahlah theta tu berapa, tetapi kalau kita tengok F cos theta atau F sin theta yang akan bagi value, definitely F sin theta yang akan bagi value. Sebab kalau kita nak make sure benda ni berpusing, kita tak boleh tarik force ke arah F cos theta. Mana nak gerak? Macam mana nak ada gerak? Sebab itulah dalam figure A, kita akan dapat zero torque. Okay, when the force is parallel to the lever arm, then the torque is zero. Okay, torque will be zero. Sebab tu boleh dikatakan, okay, memudahkan kita untuk faham. So torque memanglah R cross F. Tetapi kalau kita boleh tulis balik, what is torque? Ialah RF sin theta. Maksud dia apa? Maksud dia ialah R, okay, akan kali dengan F sin theta. Kenapa F sin theta? Okay, sebab theta itu duduk di antara force dengan lever arm macam ni. Maksud dia kata kalau ini adalah lever arm, okay, dan ini adalah force. So this should be the theta. So kalau theta dekat situ, so kita akan dapat dekat sini F sin theta, yang dekat atas ni F cos theta. Senang cerita, okay, memudahkan kita faham what is the component of force that cause a torque. Okay, sebenarnya we must make sure, okay, the component of force that perpendicular to the lever arm. Okay, component of force that perpendicular to the lever arm should give you torque. In this case, F sin theta. Okay, in this case, F sin theta. Maksud dia, apa-apa pun kalau kita nak calculate torque, if you want to calculate torque, we must make sure, okay, we find if we find what will be the component of force that perpendicular to the displacement, to the R. Dengan cerita ya. Okay, kalau dalam work dulu, W equals to FD. Okay, we always get the component of force that parallel to the displacement. Okay, dalam work dulu, kita ambil component of force parallel dengan displacement. Sebab W equals to FD, dia, kalau kita buka dia, jadi FD cos theta. Okay, FD cos theta. But in this case, torque is also RF. Tapi dia tak tulis FR lah. Dia tulis FRF. Kenapa? Sebab susunan dia lain. Kalau R kali R cross F tak sama dengan F cross R. Because of the directions. Okay. Okay, but RF sin theta. So sebab tu dia susun macam tu. RF sin theta. So F sin theta will be the perpendicular. The component of force that perpendicular ni dia. Perpendicular to the level arm. What is level arm? Level arm tadi dia lah. Ataupun distance lah. Senang cerita distance ke, level arm ke. Kan? Anything yang awak rasa, awak faham mengenai R. Okay, sometimes we can call that distance. Sometimes we can call that level arm. Sometimes we can call that as radius. Okay, that depends on the situations. Okay, so in this case, if this boy want to make this revolving playground, okay, rotates as it is, okay, so he must make sure that he should push this card, okay, these things at a certain angle, Maksudnya boleh tak kalau kita tarik dia pada dalam zero angle, dalam theta yang macam part A, boleh ke? Tak boleh. Because in part A, the theta will be 0. And what happened when the theta 0? Masukkan theta 0 dekat situ. If the theta is 0, so what happened is sine 0 equals to 0. So definitely the top will be 0. But if you put that, the sine theta like this, okay, that means theta equals to 90 degree. So say sine 90 degree will be 1. Which means the maximum theta. Okay, that should be the conclusion of what should you use the components of force that cause a torque. So definitely we must make sure the component of force must be perpendicular to the distance. Must be perpendicular to the distance or level arm or radius. Remember, okay? So for torque, the tangential component of force must be, okay, tangent or component perpendicular to the distance. Okay, sorry, I've lost something. Right? So make sure you understand this word first. Okay, so again, torque equals to R cross F. So how to write it up? So RF sine theta. Okay, torque is equivalent to, I put the magnitude over there, meaning that the theta should have a significant value. So meaning that we can find its value RF sine theta in Newton meter without thinking about directions. Okay, so that's why we need to understand that this torque have magnitude and directions. Ada soalan tak? Ada soalan? Before we proceed. Okay. If you want to ask me, just put in the chat box, okay? Kalau ada soalan pun boleh stop saya saja ya. Alright, this leads to a more general definitions of torque. Okay, so again, I should remind you that torque is equivalent to RF. Okay, R cross F, but if in the good form, torque is equivalent to RF sine theta, meaning that we should get f sine theta. What is f sine theta? Okay, component of force that perpendicular to the distance or displacement. Okay, so that should be, let's see if you do have a circle or a motions of these things. Okay, the motions of these things against the center of rotation. This is center. Okay, we should always locate where is the center of rotation, or else we cannot find where is R, because a center of rotation, the length between center of rotation to the force is called lever arm. Okay, this one is called displacement. Maybe somebody will call it as lever arm. Maybe somebody will call it as a radius. Okay, obviously for the round object like this, you can call it a radius. So let's see if you do f like this. So what should you do? Okay, you should divide it. You should make, you have to be able to make sure to do some, okay, like this. Okay, we should divide this thing into components. Let's say this is f cos theta and this one is f sine theta. And remember that will only give the value if the theta is in between. Okay, it's like this. Dalam dua-dua contoh yang kita tengok sebelum ni, kedua-dua theta duduk di antara force dan juga parallel parallel directions. Dia duduk dekat situ. Kalau tiba-tiba dia bagi theta di arah lain, dan kita kena buat komponen yang baru. Sebab tu jangan hafal F sin theta ke apa ke. Yang penting kita faham R, F. Tapi F yang mana? F yang perpendicular. So F yang perpendicular baru kita check dalam figure tu macam mana bentuk dia. Okay. So don't jump to the conclusion. It's always be R, F sin theta. Okay. Okay, let's look at the examples, very quick examples. Okay. If the torque causes a counterclockwise angular acceleration, it is positive. If it causes a clockwise angular acceleration, it is negative. So how to determine either the torque is positive or negative? Okay, it's very hard, okay, to show you like that. Okay, if the torque causes a counterclockwise angular acceleration, is it positive? So meaning that when the forces apply to a certain value, let's say F1 and F2, okay, so in F1, when we see F1, so we definitely know that F1 will come with the F1 cos 50 and also F1 sine 50. Okay, and F2, because of its okay, F2 already in the tangential forces, so F2 is, okay, kita tak perlu nak convert dia kepada component, tak perlu lagi. Okay, kita terus ambil nilai F2. So how to know that these forces going to the clockwise or counterclockwise? Okay, so definitely very easy. So let's look at F2 first. The F2, bayangkan kalau ada tali yang ikat daripada F2 tu ke rod ni. Okay, let's say this one is your center of rotations. Okay, tali yang duduk dekat situ. So apa yang you buat ialah you ambil satu, bayangkan kalau ada satu tali ikat dekat F2, lepas tu F2 kita tarik. Agak-agak roda ni akan pergi ke arah mana? Plus, is it clockwise or counterclockwise untuk F2?
Clockwise.
Okay, so F2 will give you clockwise position. Betul? Thank you. Right? So it will give you clockwise position. Sebab apa? Bayangkan kalau ada tali ikat dia dekat center of rotation, lepas tu F2 tarik. Okay, F2 tarik ke kanan dan akhirnya roda ni akan berputar ke arah clockwise. So definitely F2 ni kalau kita calculate torque dia, nilai dia akan jadi negative value. Okay. Sebab for the clockwise, okay, nampak dia bagi tahu it is negative. Okay. And how about F1? F1, kita nak consider yang mana? F1 cos 50 ataupun F1 sin 50? Okay. Definitely kita akan ambil F1 yang perpendicular. Perpendicular dengan level arm. So this is perpendicular dengan level arm, which is F1 sin 50. So F1 sin 50, definitely, kita cuba ikat balik. Ikat tali dekat F1, lepas tu tengok F1 ni akan tarik ke arah mana. Definitely dia akan buatkan tarikan dia ke arah sana, which means ke arah counterclockwise. So in the counterclockwise position, the direction should be positive. The directions of torque could be positive. So when we want to calculate T net or the net torque, so we should add T1 plus T2 because that should be the net. Okay, T1 plus T2. So T1 apa tadi? Positive value. Okay. Plus dengan T2 negative value. So nanti dia akan dapat, katalah, let's say your T1 give you about maybe 40. Okay, and T2 will give you negative 20. So it should give you 40 plus with negative 20. So the answer will be 20 Newton meters. So okay, is it the final answer? No, it's not yet. So you should put it as counterclockwise. Okay, you should put it as counterclockwise. Then you have a magnitude and you have the direction. So that's how you should put your answers in the final answers. Okay, so you should do it properly. Okay. You must understand the torque will have a positive and negative depending on the situation, depending on the directions, maybe going to the clockwise or counterclockwise. It's very easy in the rotational motion because rotational will only involve counterclockwise or clockwise position. Okay, dia tak akan pergi kiri, kanan, atas, bawah macam tu. Dia hanya pergi ke counterclockwise ataupun lawan arah jam ataupun ikut arah jam. So rotation ni ada dua direction. So that's why it's very crucial to understand positive and negative. Ada nampak presentation ke? Sorry guys, I have to stop you. Ada nampak presentation ke?
Nampak.
Nampak Okay. Can carry on. Because kalau ikut arah jam, nilai dia negatif. Kalau lawan arah jam, nilai dia dah positif. Tetapi ada juga there are some books or reference book that have a vice versa. So that will give you a certain, kan pening pula awak kan. Awak baca buku ni, buku ni kata kalau clockwise positif, kalau counterclockwise dan negatif. Oh, sebenarnya dia tak kisah pun awak nak follow yang mana, tetapi in our terms, in our own view, okay, based on your textbook or your survey textbook, the torque is a positive when it is in the counterclockwise position, and it's a negative when it is in a clockwise positions. So that's why we have to follow the rules, okay? So ada juga buku-buku yang akan ceritakan. So that depends. Yang penting kita kena faham clockwise dengan counterclockwise mesti beza value. Okay? Maksud saya kalau clockwise awak set dia sebagai negatif, counterclockwise sebagai positif. So mesti ada convention macam tu supaya you come to the same conclusions. Okay. So let's look at these examples. Okay, very good example. Two helmsmen in a disagreement about which way to turn a ship. Okay, ini kalau kamu tengok, this one is the steering lah, macam steering lah, steering untuk kapal. Kan, dia boleh pusing kan, few buat rotational pun dia boleh pusing, and sama juga dia boleh pusing ke kiri ke kanan. It's either in the clockwise or counterclockwise positions. As the force shown below on the ship wheel. Okay, the wheel has a radius 0.74. Look at the terms used in these questions. Okay, it used a radius. So radius tu sebab apa? Sebab dia R, sebab dia bentuk bulat. Okay, there will be times that during our discussion afterwards, okay, you will see the force, but it's not in the bukan dalam bulatan pun, but it still move in the rotational motion. It still move in the rotational motion. Alright, a radius of 0.74, and the two forces have the magnitudes. Okay, 72 Newton. For F1, this one is 72 Newton, and F2 is a 58 Newton, slightly below 72. Okay, find the torque caused by F1. Okay, the torque caused by F1. Again, tengok kalau kita nak kira, tengok dia ambil yang mana satu. So again, when you see the theta, especially not 90 degrees, okay, and you know that the theta is in between the directions of distance or radius. In this case, in this way, so you will learn that the theta, this one is F cos 50, and this one is F sine 50. Which one to take? Okay, so definitely we must make sure the torque is always equals to the component of force that perpendicular. Where is the perpendicular? This one. Okay, this one only. Right, so F sine 50. That's why they obtain RF sine 50. Okay, again, now take out your calculators, try to punch in the value 0.74 because it's a 0.74 meters for R, times with 72 sine 50. So you will get 41 Newton meter. Okay, 41 Newton meter. And of course, the directions play an important role over here. Why they call it value positive? Because F1, okay, as I mentioned in this case, F1 is going to the counterclockwise position, and that's why we can get F1 in the positive value. And look at the torque number 2. Okay, so the torque number 2, okay, you know that torque number 2 doesn't have to divide its component because it's already in the component. Okay, so F2 sine 50 negative. Okay, they already put negative. Okay, at the earlier calculation. Why? Because they're afraid that if they didn't put it earlier, so they will nanti bila letak kat belakang dia lupa. So senang cerita, negatif atau negatif tu boleh diletakkan last kali. Okay, as long as you know that the situation, okay, torque must involve direction. So mesti cerita dia going clockwise ataupun counterclockwise. Tak boleh kita biarkan dia tergantung dengan bacaan kosong je. So jadikan dia practice. Make it as your practice. Whenever you calculate torque, make sure it's always involved with the directions. It doesn't matter, it's going to the clockwise or counterclockwise, always have to put the directions. Okay, so in this case, the direction is going to the clockwise position and the value should be negative. And what happened in the part C, in which direction does the wheel turn as a result of these two forces? Okay, the result of these two forces based on T1, meaning that T net equals to T2 plus T1, torque number 1 plus torque number 2, and 41 Newton meter. It should be like this: 41 plus with negative 43, and that will give you negative 2 Newton meters. So where is the final directions? It must follows the negative. So which one is the follow negative? Torque number 2. So the final direction is going to the clockwise position. So we can conclude that, and we can confirm that the directions of the final torque is going following the negative one. Following. Which one is the negative? The one in the torque number 2. So definitely it will follow the clockwise positions. Okay, so the value is here. Okay, the negative means the directions, but to be on the safe side, always put the directions. Okay, going to the clockwise positions. Okay, so that will give you the one examples. All right, let's look at this swinging door. Okay, from your examples in your textbook. Okay, a man applies a force of F equals to 300 Newton at an angle of 60 degree. So meaning here, okay, 60 degree to the door of figure 8.7a. Okay, this is one 8.7a. 2 meters from the hinges. Okay, so this one is hinge 2 meters. So meaning that 2 meters is definitely distance here. Dalam ni kita tak boleh panggil lah dia radius. So kan, kita tak tahu pun, tetapi this one is door. And hinge, in this case, hinge will be the center of rotation. Center of rotations. So when you do have center of rotations with that hinge, okay, so you know that this one should be your R. Okay, 2 meters should be your R. And of course, you have force. Okay, find the torque on the door choosing the position of hinge as the axis of rotations. Okay, bear that in mind. Okay, there will be times that we can choose where is our axis of rotation, because in this case hinge also a force. Dalam cerita ni, hinge pun boleh jadi force. Force yang melekatkan pintu tu kepada orang kata alang pintu tu lah kan. Okay, so selain tu kita ada force, maknanya daripada orang tu sendirilah, daripada pintu, tombol pintu. So ada dua force sebenarnya. Tapi whenever you put a center of rotation at hinge, okay, so bila kita letakkan center of rotation dekat hinge, so kita dah eliminate force. Maksudnya kita kalau ikutkan tajuk talk ini, every forces yang involved di dalam soalan, contohnya dalam kes ini ada hinge, ada 300 Newton, we have to calculate each one of those. Okay, each one of these kita kena calculate dalam dan masukkan dalam T-net dia. Tetapi in this case, we choose the hinge as the center of rotation. Apa yang berlaku kalau kita choose hinge sebagai center of rotation? Okay, apa yang berlaku? Okay, kalau hinge ini adalah F, sebuah F lah, kata sebuah F, dan apa akan berlaku kalau kita pilih hinge sebagai center of rotation? Jadi sebenarnya dekat hinge ialah R equals to 0. Apa akan berlaku pada R equals to 0 kalau kita tengok RF sin theta? Apa akan berlaku kalau R0? Torque also will be 0. So that's why hinge kita jadikan center of rotation. Sebab tu kita dapat R itu 0. So sebab tu kita pilihkan salah satu ni. That's how we try to solve the problems. Okay. Alright. So what happened is find the top of the door choosing the position of hinge as the axis of rotation. Again, top untuk hinge dah jadi 0. Sekarang tinggal top untuk 300 Newton. So which one to choose? RF sin theta. Then remember 300. So you should divide it into 300 cos 60. This one 300 sin 60. Okay, yang mana satu kita ambil? 300 sin 60. Okay, 300 sin 60 kali dengan 2 dapat 520 Newton meters. Okay, 520 Newton meters. Okay, on part B, suppose a wedge is placed. Okay, wedge is placed 1.5 meters from the hinge. Okay, 1.5 meters from the hinge. Wedge ni macam Senang cerita macam penyendal lah, penyendal yang kita selalu letak dekat pintu kan, ada switch. Okay, okay, dia letakkan 1.5 meters from the other sides of the door. Maksudnya dia letakkan di sini lah. Switch tu dia letakkan di sini, dia punya directions ke arah pintu. Okay, ke arah pintu. Right? So, what minimum force must the witch exert so that the force applied in part A won't open the door? Cerita dia sekarang, kalau kita nak buka, dia bolehlah buka menggunakan 300 sin 60 kali dengan 2. Dapat buka. Tetapi kalau kita letak wedge, kita letak wedge, kita letak penyendal pintu 1.5 meters. Okay, kita kena letak R dia 1.5 meters. And obviously kalau kita punya torque tadi ke arah atas, wedge mesti ke arah bawah. Wedge mesti ke arah bawah lah, direction dia. Okay, maksudnya kita letak on the other side so that kita nak buka. So berapa banyak, soalan dia, what is the minimum force? Berapakah minimum force? Berapa minimum daya yang diperlukan as the wedge exerts so that the force applied in part A won't open the door. Okay, so maksudnya menggunakan kekuatan yang sama 300 Newton. So input H, kita nak letak berapa. So tengok macam mana di-calculate. So this one is the submission of torque equals to 0. Okay, tak apa. Kita tengok dulu what is submission of torque equals to 0. So maksudnya hasil tambah semua torque yang terlibat, sama kita ada hinge, kita ada wedge, dan kita ada force kan, 300 Newton tadi. So ada 3 benda yang kita kena calculate dekat situ. Definitely untuk hinge dia akan jadi kosong lah sebab dia jadi center of rotation. Untuk wedge pula dia jadi 1.5 R F sin theta. Okay, tetapi negatif 690 sebab dia ke arah bawah. And of course kalau kita tengok macam mana wedge tu boleh dikatakan negatif sebab bila kita ambil center of rotation, katakanlah ni center of rotation kita dekat hinge tu, okay, apa pula? Hinge, saya tandakan merah hinge ni. Hinge tu ke arah wedge. So kalau wedge tu tarik ke bawah, apa akan jadi kepada pintu ni? Dia akan berpusing ke arah clockwise. So clockwise ingat dia apa? Positif ataupun negatif? Jawapan dia clockwise itu ialah negatif. And force yang kita tarik gunakan 260 tadi ialah ke arah positif. So sebab itulah tengok yang ni tambah dengan yang jawapan akhir tadi. So kita dapat in the end the force of the wedge should be equivalent to 347 Newton. Okay, minimum force. So bila kita dah tambah equals to 0, so we can get the wedge of the force, the force, the wedge must exert 347 Newton of force. Okay, barulah pintu tu tak boleh buka. Dia akan tersangkut lah. Okay, so we should understand the examples, especially for the swinging door. Okay, so let's take a break for 1 or 2 minutes before we continue on the talks and the 2 conditions of equilibrium. Okay, let's take 1 minute break before we continue. And if you do have a question, please ask. Thank you. Okay, so let's continue watching the lecture. So torque, you already learned torque is equivalent to RF, in this case RF sine theta. So the conditions of static equilibrium. So before this, in the force, we learned submission of Fx equals to 0 and also submission of Fy equals to 0. So that is based on, let's say, if you do have a picture, you want to hang it, or maybe you have a traffic light, you want to hang these things, okay, at a certain T, okay, T1 and T2. Okay, so these things is considered as a object in static equilibrium. It doesn't move because it doesn't move in x-axis and also y-axis. So this one is projection by fx equals to 0 and fy equals to 0. But okay, using another when we apply torque into the situation, we should also involve the submission of torque equals to 0. So right now, a part of you have fx equals to 0 and fy equals to 0. Now you have submission of torque equals to 0. So let's look at the situation. Okay, so a child of mass m is supported on a light plane by his parents who exert the force F1 and F2 as indicated. Okay, his parents have F1, his mother is F1 and his father is F2. Okay, a projection of F is going upwards. Okay, find the forces required to keep the plane in static equilibrium. So in this case, this child have mg that's going downwards. Okay, so which one will have? We'll use the right end of plane as the axis of rotation. Okay, use the right end of plane, meaning that here. Okay, so find the force required to keep the plane in static equilibrium. Okay, to keep the plane in static equilibrium. Okay, so the first one is set the net force acting on a plane equals to 0. So we can say that in the y, okay, summation of Fy equals to 0 in the y direction is very easy. Everything goes up, okay, should put as a, meaning that in this case F1, F2, F1 plus F2 because mg is going downwards, then equal minus mg equals to 0. That should be the one equations. Okay, and set the net torque acting on the plane equal to 0. Okay, equal to 0. Okay, let's say if we use the right end of the plane as the axis of rotation, definitely F2 akan jadi torque dekat torque number 2 will be 0. Okay, now we have to calculate torque number 1 and torque child. Okay, torque of the 1 and torque child. So the okay, jarak dia ialah L. Okay, so nampak untuk torque number 1 jika pakai F1, F1 will be negative. F1 kali negatif. Kenapa negatif? Kalau kita ikat daripada sini ke sini, kita angkat F1 tu ke atas. So, kita akan nampak F1 ni akan going this way. So, going that way will be clockwise. Clockwise nilai dia negatif. Okay. So, mg budak ni pula. Mg budak ni nampak kalau kita tarik mg tu ke bawah. Kita tarik dia ke arah sini. So, nampaknya maksudnya dia menuju ke arah counter clockwise. So, sebab tu jawapan dia positif. So mg kali dengan jarak dia adalah 1/4 L. Perempuan tadi jarak dia adalah L. Sebab 3/4 L campur dengan 1/4 L dapatlah 4/4 L. So dia jadi L je lah. So F1 will be half 1/4 mg. So dapatkan F masukkan dalam equation yang first, kita dapat yang kedua F2 will be 3/4 mg. So this one ialah calculation dalam bentuk pengiraan yang gantian sahaja, bukan pengiraan betul. Okay. This one also have a pengiraan. Kita skip dulu yang ni. Kita pergi pada yang lebih simple untuk kita faham ya. Okay, a lot of examples lah. Okay. Good. Okay. A woman of mass M, okay, equivalent to 55 kilogram, sits on the left end, okay, macam dalam figure tu, and of a seesaw, a plank of length L equals to 4 meters, pivoted in the middle. Pivoted in here, maksud dia macam ni lah. Okay, in the middle as in figure 8.8. First, compute the torques on the seesaw above an axis that passes through the pivot point. Soalan dia, jawapan dia, first compute the torque on the seesaw above an axis that passes through the pivot point. Okay, where should a man of mass M, 75 kilogram, M ni, mass dia, 75 kilogram, sit if the seesaw plus man and woman is to be balanced. Okay, find the normal force exerted by the pivot if the plank has a mass PM, PL equals to 12 kilogram. Okay, so nampak. Soalan pertama, first compute the torque first. Okay, compute the torque on a seesaw above an axis that passes through the pivot point. Okay, so pivot point ini akan jadi center of rotation. So, bila ada center of rotation, kita kena calculate torque ini dengan torque yang bawah. Okay. So, right. Okay, so part A, T pivot. Okay, T pivot shall definitely 0. Kenapa 0? Sebab dia jadi center of rotation. Pivot itu pun ialah satu torque. Sebab apa? Sebab kalau kita letak plank, okay, di atas objek yang tajam muncung dia macam ni, maksudnya dia pun akan bagi force. Dan jangan lupa plank ni juga disebabkan plank ini ada dia punya mass dia. Dia pun ada mass juga. Mass of the plank. Okay, so don't forget about every. Sebab dalam torque, we must consider every forces. Every forces ni, setiap weight yang ada kena calculate lah. So, perempuan ni, lelaki ni, pivot tu dia ada force ke arah atas sebab dia ada dia letakkan di atas apa plank tu atas letak atas dia kan. Bila kita letak atas satu benda mestilah tangan akan cocok ke atas kan macam tu kan. Okay, so that's why okay, pivot tu ada directions, ada normal force ke atas dia. Okay, dan plank itu pun ada mass dia sendiri lah. Dia tak bagi tahu pula masalah ya. Right? Okay, where should a man sit? So, di mana man tu kena sit dalam situation sekarang? So dalam kes ini kita akan gunakan yang pertama, submission of torque equals to 0. Okay, submission of torque. So we must consider every torque yang ada. So torque of the gravity. Apa maksud torque of the gravity ni? Okay, maksud dia adalah gravity untuk plank. Okay, gravity untuk plank tu sendiri. Okay, so plank ni ada 0 juga. Sebab plank itu dia duduk, mass dia betul-betul di atas center of rotation. So, nilai R dia akan jadi kosong. Okay. Baik. Dalam kurungan plank. Okay. And torque of the man. Okay. Dia ada X. Dia ada X. So, maksud dia mg kali dengan X. Okay. Mg kali dengan X. Dan kalau kita tengok the direction dia, adakah jadi negatif atau positif, dia akan pergi clockwise position. So, clockwise, definitely akan dapat negatif. And untuk woman, okay, dia punya value dia adalah L ditolakkan dengan L ditolakkan dengan 2 campur X ataupun L bahagi 2. L bahagi 2. Ya, betul. L bahagi 2 jarak dia ataupun 2 meters. Either one boleh ya. Either one boleh, sama ada nak guna L ataupun nak gunakan 2 meters straight away. So 2 meters. So mg kali dengan 2 meters. So mg tu kalau kita tengok direction dia must be in the counterclockwise. So dia akan dapat positif. Okay, equivalent to 0. So from this you can get x equals to 1.47 meters. M yang asal tadi ialah M apa? M untuk perempuan tu lah. M untuk perempuan tu. L itu ialah 2. 55 kali dengan 2 bahagi dengan 75. Okay, so 75 tu ialah mass of the man. So the man should sit 1.47 meters. Maksudnya bukan 2 meter tapi 1.47. Maksudnya X ni sepatutnya 1.47. Slightly dekat sikit berbanding perempuan. Okay, ya. Alright. So, on part B, find the normal force exerted by the pivot if the plank has a mass 12 kg. So, dalam situation ini, kita akan menggunakan submission of Fy equals to 0. Kenapa kita gunakan submission of Fy? Sebab dia minta normal force. Sebab pivot tu duduk di atas surface. So, every objek yang duduk di atas surface, dia akan ada normal force. Which is, normal force tu ialah 90 degrees to the surface. Okay, so dia ada negative mg sebab negative mg lelaki, lepas tu negative mg perempuan, lepas tu negative plank kali dengan g ke bawah, semua tu ke bawah, negatif plus dengan normal force. Sebab normal force saja ke atas. So bawa semua yang lain ke sebelah kanan, so kita dapat normal force equivalent to 1390 Newton. Okay, and repeat part A, but this time compute the torque about and exist through the left end of the plank. Left end of the plank should be here. Okay, left end of the plank kita nak letak dekat perempuan ni pula sebagai pivot. Apa akan berlaku? So definitely perempuan ni akan jadi 0 lah. Kita dapat ya, mg kali dengan kosong. So everything yang lain kena calculate, nampak ya, negatif mg kali dengan L per 2 campur X. Apa maksud L per 2? Jarak lelaki tadilah. Jarak lelaki tadi bahagi dengan 2 meter dikalikan dengan X. 2 campur X je, senang 2 campur X je. Okay. Dan plank, plank pun kena calculate sebab sekarang ni axis of rotation dia dah tak ada duduk dekat pivot, tapi duduk dekat perempuan. Jadi penting kita kena faham ya. Soalan B, soalan C tu dia minta the center of rotation. Okay, kamu boleh tengok sendirilah the rest of the calculations afterwards. Okay, tapi dalam soalan C tu dia minta calculations bila perempuan tu pula jadi center of rotations. Okay, apa beza kalau perempuan tu jadi center of rotations dengan pivot itu jadi center of rotations. Okay. So in this case, we will skip this part, the center of gravity, because it's only the qualitative, and we straight away go to the this one, zero torque and the static equilibrium. We have already learned this thing. Okay, let's look at another examples. Okay. That's one examples over here, okay? Right, a 85 kilogram person stands on a lightweight ladder. Lightweight ladder meaning that we don't have to calculate the torque because the ladder is considered as lightweight. Okay, tak ada weight pun. The floor is rough, hence it exerts both a normal force F1 and a frictional force F2 on the ladder. The wall, on the other hand, is frictionless. It exerts only a normal force. Using the dimensions given in the figure, find the magnitudes of F1, F2, and F3. Okay, penting untuk kita faham soalan dan penting juga untuk kita tengok kepada situation ataupun figure itu sendiri. Okay, perempuan ni ada berat dia. Berat dia dikira sebagai mg. Sebab tu nak tengok dekat situ, berat untuk perempuan tu diletakkan di bawah, dia straight dengan dia, iaitu mg. Perlu tak kita calculate mass of the ladder? No, we don't have to calculate the mass of the ladder sebab dia memang dah lightweight. The floor is rough. Apa maksud floor is rough? Maksud dia ada friction. Kalau floor itu frictionless, maksud dia boleh tak kita letak tangga macam ni? Definitely tak boleh. Dia akan slip jatuh. Dia akan jatuh ke mana? Jatuh ke arah sana. So, disebabkan itu ada F2, which is the frictional force arah situ. And of course, bila kita letak tangga di atas, dia akan ada normal force. So, akan ada F1. Dia letak value je, dia letak value je. Maksudnya F1 itu ialah normal force untuk tangga jatuh. Dan F3, okay, F3 pula dicerita dekat wall, maksudnya tadi floor. Di wall, maksudnya dinding. Dekat dinding itu frictionless. Apa maksud dia frictionless? Maksud dia kalau kita sandarkan tangga itu ke arah wall tadi, maksud dia tangga itu tidak akan melekat dekat dinding. Mesti dia akan jatuh. Dia akan jatuh ke mana? Dia akan jatuh ke bawah. Tetapi disebabkan dia frictionless, maksudnya tidak ada friction. Okay, so tapi dalam soalan itu ada normal force. Normal force itu dia bagi tahu going to this way. Dia tak letak N ya, dia tak gunakan normal force. Dia just letakkan F1, F2 dengan F3. So we need to calculate this F1, F2 and F3 using only given. Nampak? Kalau tengok dalam soalan ini dia berbeza sedikit. Dia hanya bagi satu ketinggian tangga 3.8 meters and also jarak daripada perempuan itu ke 0.7 ke arah center of rotation. And this case, this one is the center of rotations. Dekat tempat center of rotations. Okay. So macam mana dia buat? Tengok dia menggunakan konsep segitiga. Maksudnya kalau segitiga kita akan ambil apa? Right. So kebiasaannya kita akan ambil level up. Soalan ada dua jenis. Kalau untuk bentuk soalan macam ni, kamu tengok dia boleh jadi dia gunakan level up. Maksudnya dia gunakan panjang tangga tu. Maksudnya panjang ini. Panjang dia. Maksudnya jarak daripada kaki perempuan tu ke arah center of rotations. Tetapi yang ini dia tidak guna value tu. Sebab tak ada nilai pun. Unless kalau kita carilah. Tapi tak ada value pun. Dia hanya bagi ketinggian. Maksudnya ketinggian tangga dan juga jarak daripada center of rotation ke arah perempuan tu. Tapi hanya dalam linear saja. A dengan B. Nampak ada A dengan B. So slightly different. Dia buat macam mana? F3 kali dengan A. F3 siapa? F3 ialah normal force untuk part A. Okay, F3 kali dengan A. So kita akan dapat torque. Okay, torque untuk F3 kali dengan A. Maksudnya jarak dari A tu dan kita akan dapat kali dengan 3 because F3 is considered as cos 90. Cos sin 90. F3 is also the sin 90 to the center of rotation kalikan dengan A dan kita akan dapat torque pada F3. Okay, pada F1 dengan F2 memang tak dapat sebab center of rotation dia duduk dekat situ. Okay, maksudnya F1 dengan F2 ni memang definitely kalau kita pakai yang ni tak ada terus. Yang ada ialah mg kali dengan B. Apa mg kali dengan jarak B. Okay, mg kali dengan jarak B dapatlah torque dia. Maksudnya untuk kedua-dua torque, untuk F3 kita dapat positif, untuk mg kita dapat negatif, equal to 0. So this is one equation. Okay, so from this we can calculate F3 because F3 is equivalent to mgb bagi A. Okay, mgb bagi A. So equation kedua kita dapat F2 minus F3. Mana F2 minus F3? Okay, ini dalam case submission of Fx equals to 0. Siapa Fx? F3 ke arah kiri, F2 ke arah kanan. Ada lagi tak orang lain? Tak ada. Sebab semua dia ambil F2 tolak F3 equals to 0. So F2 dengan F3 value dia 150 Newton. And how about F1? F1 dia ada satu je yang ke atas, which means satu ke atas, satu lagi ke bawah mg. So digunakan submission of Fy equals to 0. Dia akan jadi F1 minus mg equals to 0. F1 equals to mg. So F1 equals to mg jawapan dia 830 Newton. Okay, kalau kita tengok equation tu, kita tengok cara tu, berbeza dengan cara yang kita calculate. Ini. Situation sama, lebih kurang, tetapi cara dia lebih berbeza. Kenapa saya katakan cara dia berbeza? Okay, tengok soalan ini, dia tak bagi tinggi. Okay, dia just gunakan equation saja. Dia gunakan D1 dengan D2. Mungkin saya boleh highlightkan bahagian. Ya. Sekejap. Okay. Alright. Okay. Okay, katakanlah ini ya. A uniform ladder 10 meters long. Okay, maksudnya dia dah awal-awal dia dah bagi panjang dia ialah 10 meter. Okay, panjang dia 10 meter. Panjang apa tu? Panjang tangga ini sendiri tunjuk panjang dia ialah 10 meter. Okay. Kalau panjang dia 10 meter, apa yang berlaku? Maksud dia, pertengahan dia, kebiasaannya mass akan diambil daripada tengah because of the center of gravity. Kita ambil dia daripada tengah. Maksud dia, kalau tangga ini berat dia 50 Newton, so maksud dia di tengah itulah 50 Newton. Jarak dia berapa? Istilah 5 meter daripada center of rotations. If the ladder is just on the verge of slipping when it makes 50-degree angle with the ground, find the coefficients of static friction. Cerita pasal coefficient of static friction. Tiba-tiba boleh masuk pasal mu s dalam ni. So apa formula mu s? Fs ialah mu s kali dengan n. So kita nak dapatkan mu s, kita kena cari dulu Fs bahagi dengan normal force. Maksud dia kena ada satu normal force. Okay, Fs dia ke arah mana? Fs dia ke arah situlah. Baru kita dapat. So Fs bahagi dengan n, baru kita dapat mu s ya, mu s. Okay, so how to do that? Right, so using yang pertama, bagi tahu dulu, rest against a smooth vertical wall. Okay, smooth vertical wall maksud dia tidak ada friction. So bila tidak ada friction, yang ada hanyalah normal force. Maksudnya normal force dekat dinding satu, dekat floor satu, ada dua normal force ya. Okay, tetapi yang atas ni kita tak calculate lah dia punya mu. Kita calculate mu yang dekat bawah ni je. Okay, so F minus P. Okay, ataupun dalam case ini kita akan ambil Fs. Okay, Fs tolak dengan normal force dekat dinding sama dengan kosong. So F akan sama dengan P. F akan sama dengan N. Dan untuk yang XY pula, kita akan ambil N tolak 50 Newton. Dia memang dah 50 Newton ya. Dia dah weight, dia bukan mass lagi. Equals to 0. So N equals to 50 Newton. Okay, N equals to 50 Newton. Nampak siapa yang ada? Hanya ada N dan ada 50 Newton sahaja. Yang tadi, Fx hanya ada F dan ada P saja. So kita dapat N. Okay, dan yang last kali nampak bila kita dah guna kedua-dua, Fx equals to 0, Fy equals to 0, yang ketiga kita akan gunakan submission of torque. Tapi kebiasaannya, okay, dalam situation, kebiasaannya cuba gunakan submission of torque terlebih dahulu. Baru dia akan solvekan banyak benda. Okay, so gunakan submission of torque. Contoh dia yang ni, dia gunakan kalau ni kita ambil center of rotation dia duduk dekat bawah ni, maksud dia normal force dan juga Fs, so kedua-duanya akan jadi kosong. Yang tinggal hanyalah normal force yang duduk dekat dinding dengan mg ataupun weight untuk ladder tu. So that's why yang weight untuk ladder tu dapat. Okay, dan juga ini ialah Fs, normal force untuk dinding tersebut. Okay, normal force untuk dinding tersebut. In this case, normal force is equivalent to 21 Newton. Okay, normal force is 21 Newton. So in this case, 21 Newton, kita boleh masukkan ke dalam dan masukkan 21 Newton, mu s, normal force tadi 50 Newton. So mu k dia adalah 0.42. Okay, 0.42. Unit tak ada sebab dia nak cari coefficient of static friction. Okay, so itu satu contoh yang melibatkan, sama juga macam contoh tadi, cuma kali ini dia dah bagi panjang tangga tu. Bila panjang tangga tu, tengok apa yang berlaku, kita boleh calculate. Contoh kita nak calculate summation of torque untuk normal force yang kat bawah ni, ataupun summation of torque untuk ladder. So kita ambil separuh daripada ladder ialah 5 meter. Okay, straight away kita boleh guna value. Okay, ada beberapa contoh yang lain, tapi saya akan tinggalkan untuk awak study, tengok sendiri ya. Okay, dan saya akan letakkan, kita akan stop sekejap dan kita akan sambung untuk torque and angular accelerations afterwards. Okay. Gain more knowledge during your study.
Sir.
So take, yes, Syafika.
Tanya yang untuk normal force tu kan, yang sin 40 tu dari mana?
Sin 40.
Masa tambah tu.
Sekejap. Yang, sekejap ya, saya balik. Yang ni ke?
Yang kat bawah.
Okay.
Kan ada 50 Newton times 5 meter times sin 40 kan?
Sekejap. Okay. Mana dapat sin 40 tu?
Saya tak nampak macam mana boleh dapat.
Okay, dia negatif. Dia kalau kita tengok dekat situ, dia hasil daripada torque untuk friction plus dengan torque untuk normal force. Okay. Tapi torque untuk normal force ni dia buat ada dua lah kan. Satu yang betul-betul dekat dekat sini. Nampak tak saya punya arrow? Nampak kan?
Nampak.
Satu lagi P. Dua-dua ni ialah normal force. Satu normal force untuk floor, satu lagi normal force untuk wall. Okay, so normal force untuk wall kita akan yang duduk di sebelah hujung sekali. Okay, tapi normal force untuk yang N yang dekat sini, okay, nampak dia duduk pada arah Y ke atas. So kenapa dia ambil negatif 50? 50, tapi dia sebenarnya nanti kamu bukan nak calculate normal force yang N yang ni ya. Sebab normal force tu tetap kosong. Sebab dia center of rotation kita dekat O, dekat kosong So normal force ni akan kosong. Yang kita nak calculate ialah 50 Newton. So 50 Newton kali dengan 5, sebab apa? Sebab jarak dia 10 bahagi 2, tengah-tengah kan. Kita ambil tengah-tengah lah. Apa-apa bahan pun kalau tengah-tengah dia, so itu ialah dia punya center of mass. Okay, center of mass. So tengah-tengah tu ialah center of mass. Jadi di tengah-tengah ialah 50 kali dengan 5. So ini ialah dia punya F, ini ialah dia punya D, tetapi F dia tak boleh ambil 50 sahajalah sebab dia ke bawah kan. So kali dengan apa? Kali dengan sin 40. Sin 40 ni sebenarnya sama dengan cos 50. Okay, kalau awak tengok dekat sini ada 50 sudut dia, dekat sini 90. Okay, dekat sini berapa? 40.
Ada tolak je.
Betul. 40 sudut dia. Jadi 50 tu kalau kita tengok dia ada angle 40 dekat dia. Tapi dia hidden, dia tak tulis. Dia hidden. So 50 tu kalau ke arah sini. Tengok saya punya ke arah sini. Kalau satu arah dengan beam, satu arah dengan ladder, dia ialah 50 cos 40. Tapi kalau pada arah ke bawah ni, which is arah yang sepatutnya perpendicular dengan R dia, so itu adalah sin 40. Sebab tu digunakan sin 40. Boleh
Okay, boleh. Thank you, sir.
Okay. Okay, so let's continue. Okay, 0.42. Unit tak ada horizontal ikat dia. So maksudnya akan kita nampak by the wall kita ikut dulu. Kenapa start dengan summation of torque? So WB, okay, again, so sebenarnya kali kan F ini E equals to kalau is1 square Pulley dengan bagi straight 7 constant lagi kita boleh so dalam satu okay. Okay. Okay, boleh nampak Okay, so ini selanjutnya kita akan sambung, which is torque and angular accelerations. Boleh dengar? Boleh ya? Okay. Guys, can you hear me or not?
Yes, sir.
Okay. Perfect. Thank you. Okay. So this is torque and angular acceleration. So for the Newton's second law, okay, definitely kita tahu that Newton's second law is F equivalent to ma, and acceleration is equivalent to F over m. Okay, and how can we relate the torque and angular acceleration? Because we already learned about torque, and we already learned about alpha. So kita faham that torque is indirectly equation ni, torque ni sebenarnya ada kaitan dengan force, and alpha ada kaitan dengan acceleration. So because of this, so we try to combine between angular acceleration and torque, okay, together with the Newton's second law. Okay, so this is Newton's second law, A equals to F over m, and you know that, okay, alpha is equivalent to A over R, okay, because A acceleration equals to R alpha, okay, and alpha is equivalent to A over R. A over R. So just combine this value to the value that we learned that one. Okay, so meaning that we should put alpha, where is alpha? So combine the things, and together with the F equals to ma, and in the end we can get, okay, that alpha is equivalent to torque over I. Okay, torque over I. Or we can rewrite the things as torque is equivalent to I alpha. Okay, torque is equivalent to I alpha. So this is torque. Okay, this one I is the moment of inertia, and alpha is the angular acceleration. Okay, you have torque, you have angular acceleration, and you have moment of inertia. Okay, so this should be comparable to F equals to ma, which means torque can be comparable to F, I is comparable to m, and alpha is comparable to A. Comparable, right? It's not equals to, but it can compare to. So everything that we do afterwards is basically based on F equals to ma and torque equals to I alpha if it's because of the rotations. Okay, so for the I is basically mr squared. Okay, if we look further, if we look carefully, I is actually equals to mr squared. Okay, the moment of inertia is basically mass times a lever arm square or radius square. But for objects that obtain a rotational motion, such as thin cylindrical shell, for example, maybe I equals to mr squared. So we can conclude that I have a different uh, situations, have a different scenarios, and not every I will be equivalent to mr squared. So, for example, if we have solid sphere, then the I should be equivalent to 2 over 5 mr squared. Okay, while the original I is I equals to mr squared. But fortunately, you don't have to memorize all this I, because all values of I will be given in your appendix or will be given inside your question paper. So don't worry about this, about how to memorize all these values of I, because it will take space of your brain, definitely. So don't worry about that. You just concentrate on just knowing what is I. Okay, what is actually I, right? So let's look at the examples here. Okay, the examples of how to use it. Torque equals to I alpha. Okay, so if you do have a problem, then please notify me. Okay, so a baseball player loosening up his arm before a game tosses a 0.15 kilogram baseball using only the rotation of his forearm. In the rotation of his forearm to accelerate the ball. The forearm has a mass of 1.5 kilogram 1.5 kilogram and a length of 0.35 meters. Okay, the ball starts at rest. The ball starts at rest. Okay, so this is the words that you should underline. The ball starts at rest, meaning that v naught equals to 0 and is released with a speed of 30 meters in 0.3 seconds. Okay, find the constant angular acceleration. What we want to find? What is alpha? Okay, what is alpha? Right. So omega equals to omega naught plus alpha t. So you need to find what is alpha. You know that omega naught is 0. And of course, omega is equivalent to alpha t. Alpha equivalent to omega over t. So what is omega? 30. Okay, a value of 30. But occasionally, the one that give the question gave us a 30 meter per second. So it's not really omega, because 30 meter per second is v. So we know that v is equivalent to r omega, and of course, okay, so in order to get omega, omega is v over r. So you get this v over r over here, and then you know alpha is equivalent to v over r times t. So then you can put 30 at v, and the radius is 0.35. Sorry, the radius is the length of the from the forearm to the ball is 0.35, and t is 0.3 seconds. Okay, and then of course the alpha will be given the equation 286 radian per second square. Look at the unit used. Okay, radian per second square. That should be the alpha. Okay, and part B, calculate the moment of inertia of the system consisting of the forearm and the ball. Okay, forearm and the ball. And the ball is basically a solid. Is maybe the ball should be like this one, hoop or thin cylindrical shell, meaning that it must contain bukan penuh lah, maksudnya dalam mesti ada benda kan. So kalau bola baseball biasanya gunakan mr squared. So kita dapat value ni. Untuk forearm biasanya kita pusing dekat mana? Kat hujung. So dia akan jadi 1.3 ml square. So 1.3 ml square. So get those value, and the system will be plus of I, a moment of inertia ball together with your forearm, and then you get I. Okay, and this, then try to put all the values. Torque equals to I alpha, because we want to find torque. So I is this one and alpha is this one. So you will get something that equivalent to let me do some kind of calculation because you cannot see over there. All right, so 7.97 times 10 the power of -2, okay, times with 286, okay, 286 radian per second square. The answer will be 22.79 Newton meters. Okay, 22.79 Newton meters. Okay, so that is good. This is a very good examples where we can connect between the rotational kinematics, the one that we learned last week, and the one we learned today. Okay, rotational kinematics together with rotational dynamics. Okay, so another example, a light rope wrapped around a disc-shaped pulley. Disc-shaped pulley meaning that this one is half mr squared. Okay, so because it's given, inside here is this, okay, pulley of this is pulled tangentially with a force of, this is what this one is your force. Okay, find the angular acceleration of the pulley, so find alpha. Okay, so you need to find alpha because so you have R and F, so 0.11 times with your F, you get the torque, and then you get I, and then afterwards you can get alpha. Look at the question thoroughly because sometimes you miss one word. Let's say you miss angular, and then you can just calculate A, so that will give you wrong answers. Okay, so make sure tengok betul-betul dia punya questions there. Okay, right? So once again, we have analogies between linear and angular motions, which contains a mass. Okay, acceleration and force can be comparable to mass, comparable to moments of inertia, A comparable to alpha, and F comparable to torque, right? So there's a few equations, few questions you can look forward. Okay, maybe we try to understand, we try to solve one problems using this. Let's say, for example, 5.8, an object has moment of inertia. Okay, so just point out the moment of inertia. So this would be I. About a fixed axis. A torque acts on the object initially at rest, so that the angular velocity, so this is omega. Okay, initially at rest, meaning that omega naught equals to 0, omega equals to a certain value. Okay, increases at a constant rate of 360 RPM. Okay, 360 RPM is not an SI unit. Okay, it's not an SI unit, so you need to convert it to radian per second. Okay, in what? In t equals to 60 seconds. Determine the magnitude of torque. So you know torque is equivalent to I alpha. Okay, so what is alpha? Again, I equals to omega minus omega naught over t. So you need to find what is omega, because omega you need to convert it from 360 RPM to convert it and put it here. So therefore, the answer should be like this. Okay, and of course, alpha is equivalent to 2 pi radian, or 2 pi radian per second square, and you put it here. And the final answer, the torque will be equivalent to 31 Newton meters. Okay, look at the unit. And the unit is very important. When you get this wrong, okay, it might cause the whole thing to get wrong. Okay, let's look at one example about the falling bucket. Okay, a solid, uniform, frictionless cylindrical reel of mass m, okay, noted here as 3 kilogram, and radius r equals to 0.4 meters. Okay, meaning that the radius is 0.4 meters, is used to draw water from well. Okay, kita nak ambil air daripada telaga menggunakan wheel. Okay, a bucket of mass m equals to 2 kilogram. A bucket of mass m. Okay, so maksudnya this one is a bucket. Okay, you have one system, you have one wheel system, and the other one is you have is attached to a cord that is wrapped around the cylinder. Okay, and find the tension T in the cord and acceleration A of the bucket. So look carefully at the situation, because this situation will combine okay, the one that we did in the rotational kinematics to the one that we did in the force. Okay, because this is actually about pulley. Okay, but I have to mention that the pulley that we did during our force chapters, okay, is based on the massless pulley. Okay, so we doesn't include the mass of the pulley, so that's why we also always ignore the mass of the pulley in the beginning of the chapter, or the beginning of the one that we did in the first chapter. Okay, so it doesn't mention anything about mass of the pulley. Okay, but in this case, in this example, it mentioned earlier about pulley, about wheel. Okay, about real. Okay, and how the cylindrical, okay, it also can elaborate about the a solid, uniform, cylindrical reel. Okay, so meaning that once you to calculate, okay, to calculate the moments of this reel. Okay, so meaning that this one, it doesn't involve only force and normal acceleration. Okay, it should include the moments of inertia together in this case. Okay, not looking. That's why the topics of rotational and the linear is always related to each other whenever it comes to the rotational part. Okay, so how to do that, right? So can get here at part A, find the tension T in the cord. Okay, T in the cord meaning that you want to find T. And you know that mg is going downwards. So MA, okay, you can write down as the summation of F equals to MA. So meaning that T is going upwards minus mg equals to MA. Okay, the same goes to this part, right? Okay, so what is delta summation of torque? Okay, because before this, you learn about summation of Fx equals to 0, okay, summation of Fy equals to 0, summation of torque equals to 0. So summation of torque right now, okay, this one is for static, okay, static equilibrium. But for the object that move, torque will be equivalent to I alpha. So what is your I? So based on solid cylinder, the I should be equivalent to half mr square. Half mr square. So times with alpha. Okay, times with alpha, because torque is equivalent to I alpha. So what happened next is, okay, the torque here, okay, based on the torque on this part, okay, you know that the torque, apa, di sini ada R dia, so inilah center of rotation. So torque ialah based on tali-tali tu jatuh ke bawah kan, ditarik, okay, itu tension. So dekat sini baru kita nampak ada tali yang akan pegang pail tadi, okay, tali yang pegang pail tadi. So sini ada mg. So two system, okay, this system and also the pulley kat atas tu. So dekat atas tu tali dia, T dia is going downwards, and we know when the tali is going downwards, okay, rotational, kita cuba pusingkan dia, kita nampak dia ke arah mana ni? Ke arah clockwise. So clockwise will give you negative. So that's why dekat sini ada negative TR. Negative TR equals to half mr square alpha. Okay. Okay, tadi kita dah ada satu equation. Equation pertama yang ni, equation kedua yang ni. So what happen next? Kita cuba combine dia, because T equivalent to MA plus G, right? So cuba masukkan balik equation tu, and we know that A, okay, R dengan R kita akan matikan. Okay, R dengan R, satu R tertinggal. Cuba try to remember that A times dengan tu kita boleh simplify kan dia. Simplify, in the end kita akan dapat, okay, T is equivalent to half 1/2 yang dibawa ke sana, 1/2 MR alpha. Okay, MR alpha. And what happen next is, okay, kita ingat alpha A ialah R alpha. A ialah R alpha. So kita dapat half MA. Okay. So in this case, okay, try to masukkan dalam equation kat atas tu. Okay. Dan kita boleh simplifykan dengan this one. Dapatlah A equals to negative 5.6 meter per second square and T equals to 8.4 Newton. Very good examples. Okay, please look forward to this kind of questions. Very good examples, especially for those who have textbook. Please look to these examples. Okay, very good. All right. So the last part in the chapter will be the angular momentum. Okay, the angular momentum. So it's talking about because we already did. Okay, we know that momentum in the linear have mass times velocity. Okay, mass kali dengan velocity. So in this case, mass kita define sebagai I. Okay, macam tadi lah, okay, moment, and V kita discuss sebagai W, which means omega. I times omega we get L. So this one is in the linear part. This one is the rotational part. Okay, L equals to I omega and P equals to mv. And we try to relate between P and L, so it becomes L equivalent to Rp. Okay, so it's just the same as torque equals to R times F. Okay, L equals to Rp and torque equals to Rf. Now you do the unit for L is kgms, kgm square over S. Okay, kgm square over S. Okay, it's not the same as torque. Torque has a Newton meter, and for the angular momentum, you can have kgm square over S. Okay, right? So look at the rate at which angular momentum change. We can also relate it with the torque equals to LT. So the Newton's second law, torque equals to I alpha, is also equivalent to the rate of change of the angular momentum. All right. So that should be the end of the chapters for the for the rotational kinematics and rotational dynamics. So next week we will learn chapter 8. Okay, maybe chapter 8 about the next topic. Okay, so I think if you do you have a problem? Do you have any questions so far?